Hello everyone, welcome back to the series of complete DSA using Python, specially designed for data science and artificial intelligence. This is the third session in this series, and today we will cover the time complexity analysis in terms of loops, loop based code. Later on we will also cover the time complexity analysis in terms of recursive codes. So what will be the outcome of today's session? You will be able to find out the time complexity of any algorithm, any program, any loop based program. You pick any code from internet, you will be able to find out the time complexity of that after the completion of this session. So let's proceed with this session. So let me start with this. Okay, let me start with the type of complexity functions. So these are some most important type of complexity functions. There are some more also, but these are the most common one. Other we can make up by combining these complexity function. We can create other complexity functions. So first of all, what is complexity function? So complexity function is nothing just that are different category of the complexity, either space complexity or time complexity. You can represent in term of these complexity functions. These complexity functions are telling that okay, which algorithm is taking how much time. We are putting them into different classes, different categories. These are different category: constant, logarithmic, linear, quadratic, so on. So these are just putting one type of algorithm in one category, and we are able to know that okay, if some algorithm is taking constant time, that is into this category, and if some algorithm is taking exponential time, that is put into this category. And we can then compare that okay, which is taking more time, which is taking less time. Here constant is taking less time, exponential is taking more time. So these are some most common complexity functions which help us to put up the complexity of all the algorithms in different categories. So these are different categories we can put up, and we can see okay, which algorithm is taking more time, which is taking less time. You can pause this screen and you can let me know. You can write in the comment section okay, that okay, which algorithm is taking maximum time over here, which complexity function is showing that okay, that will take the maximum time, or which will take minimum time. You may pause the screen and you can try it, but right now okay, I'm telling you exponential is taking the maximum time, and after that polynomial is taking. So minimum time taken is by constant function. So the algorithm which is taking order of 1 time, they are taking a minimum time, and after that more than order of 1 is log n, more than log n is n, more than n is n square, more than n square is n cube, n power k. K is constant over here, n is a variable over here in the case of polynomial, okay, and in the case of exponential, n is the variable, c is the constant. Okay, c might be constant or variable also even. So for example, if I take the example over here, 2 power n is exponential and n power n is also exponential. So these categories coming into the exponential, which is taking maximum time. So simple. These complexity functions are helping us to put all the complexity in these categories, and we can see okay, which is taking less time, which is taking how much more time. Fine, okay, let's move on. Any doubt if coming in your mind, you can share in the comment section also. I will reply to each and every doubt. Definitely I will reply over there for each and every doubt. That is my promise. So here we are showing okay, order of growth means this is taking minimum time, this is taking more than constant, this is taking more than logarithmic. So this is growing like this. This is just showing that okay, which is taking less time, which is taking more time. This function will grow with less speed as we will start giving the input. As we are increasing the input, which function is growing faster? This function is growing most faster. Okay, the value of this will increase very fast as compared to the value of lower functions. So if the value is increasing less, they are less expensive, and the value is increasing more, they are more expensive. Means they are taking more time, or you can say more space complexity. We will talk about space complexity later on. In this session we are talking about the time complexity only. Fine, okay, so this is the same thing, complexity functions, how they are growing. Constant taking minimum time, exponential is taking maximum time. Fine, let's move on, and I will take some small codes now Through these codes, I will try to cover each and every type of scenario, each and every type of complexity that can be generated. Okay, so with small codes, you people can also try at your end. What you can do, you can pause the screen and you can try it, then listen to me. This will give you the best learning, believe me. If you will pause every screen now onward and think yourself first, then listen to me, greater results you will find out. Okay, otherwise I'm going at my end. Example 1, can you tell me how much time this code will take? How much time this code will take? Here we can see that, okay, one loop is there. This function is defined over here. In this function we have a loop which is executing 10 times. We are calling this function, okay, over here. So even before that, let me give you one definition also. One definition of finding the time complexity of any algorithm. With this definition, you will be able to find out the time complexity of any code. Any code. Let me write over here, okay. This is the definition you can take. Okay. Finding the time complexity, let me write. Finding the time complexity of an algorithm means finding that part of the algorithm which is taking maximum time. So this definition you can apply to any code to find out its time complexity. What this definition is say that if you want to find out the time complexity of any code, find out that part in the program, find out that part in the complete code which is taking maximum time. How much that part which is taking maximum time, how much that part is taking, that is the time complexity. So in this code, if I apply this definition over here, in this code, if you see which part is taking maximum time, out of complete code, which part is taking maximum time, here this loop is taking maximum time. This loop will execute again and again and again. Other part will execute one time. This statement will execute one time. This statement will execute one time. Only this part will keep executing 10 times in this case. Okay, so this is the part which is executing maximum time. So we need to find out, that's it, which part is taking maximum time. That will decide the time complexity of an algorithm. Fine. So here this part, this loop is taking maximum time. So the time complexity will depend upon how much time this loop is executing. How much time this loop is executing? This loop is executing 10 times. I can say that, okay, this will take order of 10 times. This code will take how much time? Order of 10. And 10 is constant over here. Whenever you find the time complexity, any constant, any number, any constant, put it into the constant category. So we know that this is one of the category of complexity functions. Whenever you find out any constant number, whenever you are finding some loop, some recursion is executing constant amount of time, 10 times, 100 times, then put them into this category. Even I replace this with 100. I say that, okay, this loop is executing 100 times. How much time this will take? This will take order of 100 times. This will take order of 100 times. I can put it into this category. I can say that 100 is constant, that is fixed. Whenever you are finding that, okay, code is executing fixed amount of time, irrespective of the input, there is no input we are taking over here. Irrespective of the input, if code is executing fixed amount of time, then put it into the constant category. Okay, fine, that's it. Even I can replace this 100 with 10,000 or 1 lakh. Some people still not believe me. Okay, let me write some more zero. Some more zero I am putting over here. Some more zero. I can fill this board with zeros. Okay, I can spend my life also to fill all these zeros. Fine. Still, this is a constant number. This is a constant number. This loop is executing how much time? Constant. Some constant number of time. Fixed number of time. Put it into this category. Order of 1. Put it into this category. So whenever you see that, okay, the code is executing fixed amount of time, irrespective of the input, then put that into this category. Order of 1, order of 1. Fine, fine, okay, there might be one question otherwise that might, usually people ask me in class that, okay, sir, how you can say that, okay, order of 1 is same as order of 1 billion or 1 trillion, whatever. How you can say that this and this time complexity is same? Actually, this is not my fault. I'm not saying this thing. This is what software industry is saying. I'm not saying this thing. They are saying that, see, their logic is also nice. They are saying that we are not bothered if you are taking 1 billion or 1. If you are executing one statement or 1 billion statement. If my user is not impacted, if my user is not waiting, to execute the code, we don't bother. We put both of them into the same class. And here, how many times this loop is executing? User is not bothered about that. You may execute this code, and when user come maybe later on, you can immediately show the solution. Either 1 time, 100 time, 1000 time, billion time. How many times you want to print hello chacha, how is chachi? You can print it in advance. Immediately the user come, you can show it. You can show him that, okay, this is the output directly. So either you print 1 billion time or 1 time. Software industry is not bothered. If their user is not impacted, they are not bothered. Their user should not wait. So here this code is not waiting for the input. So that's why this is taking constant time. Fine, okay. So simple idea here is that, when we are executing fixed amount of time, either 10, 100, 1000, billion, I don't know, you will put that into the category of order of 1, constant. Put that into the constant category. Fine, done. Let me move on to the next slide now. Second example. Now we are taking some input. From the user. Okay, we are taking some number. Then we are executing this loop. Again, you can pause the screen and you can try yourself. It's a better idea. You pause the screen and try it first yourself. You will then enjoy more. Otherwise, I'm trying it at my end. How many times this loop will execute? How many times? See, we are taking n input from the user and this loop is executing n time. Here we are incrementing by 1, every time 1. So starting from 1 and we are going to n, one by one, taking one step at a time. 1, 2, 3, 4, 5, 6, so on, taking one step. In how many steps we will reach to the n? N steps. How many times this loop will execute? N time. Because you started from 1, incrementing every time by 1. 1, 2, 3, like this way. So how many times this loop will execute? N time. Simple. So this loop will execute order of n time. Simple. You put it into this category now. So whenever user say that, okay, my input is n, so he need to wait for n time to print this output. So complexity is order of n. One more thing I want to add over here, okay? One extra information I'm adding. I'm using a word order of. This symbol I'm using. Right now, what you can think of, what you mean by this symbol is, this symbol you can replace with English word. You can replace it with approximate. You can say that approximately I'm taking n time. Approximately. Order of means approximately you are taking n time. Approximately. Why I'm saying approximately? Because there is some other code also. I'm not considering that. This is also executing 1 time. This statement is also executing 1 time. This statement is also executing 1 time. This is also executing 1 time. I just consider this loop itself. I do not consider 1, 2, 3, 4 these. The complexity might be, I can write, okay, order of n plus 4. This is also fine. Even this is more accurate. But this symbol is giving me the opportunity that, okay, you can remove the constant. Because we are finding approximate time complexity. We are not bothered about the constant. Okay, constant do not make big impact. What make the impact? This variable. This variable make the impact. Any doubt, write in the comment section. I will answer each and every doubt over there. Believe me. Fine, okay. Otherwise, I'm moving on. With the next example. Can you tell me? Okay, yes, this is taking order of n time. Third example we have with us. Again, you can pause the screen and you can try at your end. In every class I find out that 80% student fail to answer this question. So you can try it, and you can think this will help us to learn better way. Otherwise I'm trying it at my end. How much time this will take? Many of the people might think that okay, this code will take how much time? N square time. And why they are saying n square? They might think that this loop is executing n time, and there is a loop inside loop over here. Two loops are there, loop inside loop. Outer loop is executing n, inner loop is executing n. When there is a loop inside loop, we multiply. So what will be the time complexity? N into n. That is n square. This part of the program is taking maximum time. So this is the time complexity. That's it. This is the time complexity. You can just take it with the definition itself. The part which is taking maximum time, this part is taking maximum time. So this is the time complexity, order of n square. But if you will notice, here is that n value is constant over here. N value is constant. Gate people usually play these tricks. Okay. So they play a trick over there that okay, they are not taking n as an input. N is fixed over here. So because n is fixed, this loop will execute 10 times. What about these two loops? Outer loop will execute 10 times. Inner loop will also execute 10 times. 10 into 10, 100 times. So what is the time complexity? Order of 100. And which is a constant. So time complexity exactly for this code right now is constant. Why? Because of this. We have defined the n value as a constant over here. Okay. So this is the gate question itself I have taken from previous year. Otherwise, if you are saying that sir, if we are taking this as an input, if we are receiving this as an input, okay, we are receiving from the user, okay, if we are receiving it from the user, then this loop will take n time, this both loop will take n square time. Then you can say that okay, the time complexity is n square. Or you can write in more better way. You can consider this thing also. Or some constant time for this 1 and 1, 2 more statement, okay, maybe 3 more. Doesn't matter, 1, 2, 3, 4, 10, 100, doesn't matter. All we will remove. Whatever constant is there, we will throw him away. So remove the constant, as well as one more thing you need to remove, lower order term. So out of this term and this term, this is lower order term. The growth rate of this term is less as compared to this. The growth rate of this term is less as compared to this. If you will give n value, let's suppose 1000 over here, this will be 1000 into 1000. And what will be this? This will be 1000 only. So this is a big difference. Big difference between this and this. And I'm taking 1000, what about 10,000? What about 1 lakh or 10 lakh? So if I will keep increasing the n value, this will be very big as compared to n. So this is the lower order term. This will not make the big impact. We can remove this also. Okay. So what I am telling you right now is that if the complexity is like this, okay, let me write it again. The complexity is like this. Order of n square plus n plus some constant. Okay. Let's suppose 3 over here. So remove the constant, that is not going to make the impact. Remove the lower order term. So two things we need to remove. Constant factor. Second thing, lower order terms. So this is the lower order term. Remove this, and this is the constant factor. So remove every time these two. Remaining is your time complexity. Otherwise we are saying that approximate. We are finding the approximate time complexity. We are not bothered about, software industry is not bothered about exact time complexity. They are bothered about, okay, what is the approximate time complexity, okay, which is the biggest factor which is impacting, okay, which is the biggest factor that is impacting the code. They are bothered about that. Fine, okay. Now let's move on to the next example. Any doubt, anywhere, I will be available with you people in the comment section. Don't forget, Try this example yourself, pause the screen, try it yourself for better learning. Otherwise, I'm trying it at my end. So what is the time complexity of this code? We are taking some input from the user. There's a loop over here. How many times this loop is executing? How many times this loop is executing? That is the time complexity. How many times the loop is executing? How many times this code is executing? This code is executing the maximum time out of all the code. All the code is this statement executing one time. This is the part only which is executing many times. So how many times this loop is executing? Fine, okay. Let me give you a thumb rule. The moment you see multiply, see in the increment section, this is the increment section of this loop. Increment, how the I value is increasing and reaching to n. So if we are how the I value is incrementing? Here I value is incrementing by multiply. So let me give you a thumb rule. So when you see a multiply in the increment section or a divide, multiply or divide simply says that close your eyes, keep your hand on your heart, simply says that the time complexity is log n. Take the thumb rule. Otherwise, if you want the mathematical proof, that will also take 2 more minutes. Let me prove it by mathematics. If you are not able to understand mathematics, don't need to worry. Just follow the thumb rule. That will work everywhere. You can follow this thumb rule. Otherwise, we can prove it. How this code is taking, this loop is executing log n time. How many times this loop is executing? Log n time. And that is the time complexity, log n. So let me remove this, make some space and try to prove it mathematically. Let me go through it. I just need to see how many times this loop is executing. First, initially the I value is 1, okay. When I value is 1, this loop is executed. We come inside and now we multiply I with 1 with 2. I value is 1. 1 with 2, that is 2. Now I value is how much? 2. When I value is 2, again we go inside the loop. We print it. Okay, it's okay. We print that. And then again we multiply the value with 2. Every time we are doubling the value, multiplying the value, previous value with 2. So this will be 2 into 2, 4. Or I can write 2 power 2. So whatever is the previous value of I, every time we are multiplying it with 2 only. Every time we are doing this. So next will be 2 power 2 into 2, 2 power 3. 2 power 3 into 2, 2 power 4. 2 power 4 into 2, 2 power 5. So on, we will keep moving on up to, let's suppose, 2 power k. And when I will reach somewhere where this will be equal to n, when we will reach to the n, we will come out of the loop. Okay. So when 2 power k will reach, this value will reach to the n, we will come out of the loop. That's it. Here, notice one thing. What is k over here? First of all, what is k? See, in the power you can see. So I can write it, okay, 2 power 0. The power is incrementing one step. 0 to 1, 1 to 2, 2 to 3, 3 to 4. So I can say that, okay, k is deciding how many time I'm going inside the loop. How many time I'm going inside the loop. So I'm going k time inside the loop. I'm going k time. So this loop is executing k time. Let me write over here. What is k? Let me write here. K is the number of times the loop is executing. And that is the time complexity. How many times the loop is executing? That is the time complexity. Just we need to find out the value of k. What is the value of k? That is the time complexity. So we can solve this equation and we can find the time complexity. We can solve, okay, 2 power k is equal to n. We can solve it by taking log both sides. So let me take log both sides. Log of 2 power k is equal to log of n. And if you know the formula of the log, let me write over here. Don't need to know. I will tell everything over here itself. Let me write over here. So there is a formula of log. Log a power b is equal to b into log a. So this formula we will use over here. Whatever is in the power, that will come in the front. You can see. Log a power b is b into log a. So here I will apply the same. So this will be k into log 2. K into log 2. Right side is same, log n. Okay, I'm taking the log base 2. Taking log base 2 so that I can make this term 1. Log 2 base 2 is 1. That is 1. So k into 1 is k. K equal to log n base 2. K is equal to log n base 2. That's it. So k, what is the k value? K value is log n. And what is k? K is telling how many times the loop is executing. And how many times the loop is executing, that is the time complexity. So the time complexity of this code is log n only. That is log n only. So this is a mathematical proof. If you're finding it difficult, go with the thumb rule. Whenever you see multiply and whenever you see divide, simply say that the time complexity or how many times this loop is executing, log n time. That is executing log n time. Fine, okay. Let me move on now, clear this screen and move to the next example. Here is the next example with us, example number 5. Almost same code is here. Just I value starting from n this time and we are going up to 1. So n to 1 we are going and every time we are decrementing the I value by 2. Decrementing the I value by 2. Earlier we were multiplying. So can you tell me how much time this will take? How much time this will take? Actually, we have already discussed. Whenever we see the multiply or divide, the time complexity is how much? Log n only. That is log n only. Okay. So this will also take log n time. This will also take log n time. Okay. Otherwise, you can find it. It's not a mathematically also we can prove it. Okay. Let me prove it. So starting I value with n. Now we will enter inside the loop. After entering the n, the I value will be n by 2. We are dividing it by 2. So initially the I value is n. In the next iteration I value will be n by 2. In the next iteration, whatever is the previous value, we are dividing by 2. So n divided by 2, divide by 2. So you can write it like n divided by 2 power 2. Okay. Again, whatever you have over here, divide it by 2. So this will be n by 2 power 3. So on n by 2 power k. So until unless this will not reach to 1, we will keep executing. So this should reach to 1. The moment this reach to 1, we will come out of the loop. Now you can solve it and find the k value. We can find the k value. What is k? How many times the loop is executing. So this is the same statement, means this will go this side, n equal to 2 power k. We have already solved this by taking log both side in previous slide. So this will give us k value as log n base 2. Log n base 2. Fine, okay. So whenever you see multiply and divide, the time complexity is log n. That's it. That's it. Let me modify this code here itself. One more thing I want to do over here. Rather than dividing with 2, if I divide with 3, then what will be the time complexity? Nothing. Log n base 3. What about if I divide with 30? Then it's okay. Base 30. Divide with 300. Base 300. Divide with 3000. Base 3000. Divide with 30,000. Base 30,000. So with what number you are dividing or with what number you are multiplying, that will decide the base of this log n. Log n will be the time complexity. That is sure. Okay. Fine. Let me remove this. Even I can go to the previous slide also. And here in place of when you are multiplying with 2, if you are multiplying with 3, then the time complexity will be log n base 3. If you are multiplying by 300, the time complexity will be log n base 300 and so on. Whatever you will multiply over here, put it that inside the base. That's it. Fine, okay. So we know that the time complexity will be log n whenever we are dividing and multiplying in the increment section. Fine. Let me move on and let's take more example. So here is our 6th example. Another different type of code. Again, I will suggest please pause the screen. Try it first yourself. Otherwise, I'm trying it at my end. We are taking an input over here. Fine. There's a loop over here. Outer loop and there is an inner loop. Outer loop is executing n time. Inner loop is also executing n time, you can notice. Okay, no, inner loop is not executing n time, sorry. Inner loop is executing log n time because we know the thumb rule. Whenever we multiply, here multiplying with 2 base 2. So inner loop is executing log n time. Outer loop, every time actually this range function will increment by default 1 step. 1 to n we will go. N time this loop is, outer loop is executing, inner loop is executing log n time. When there is a loop inside loop, multiply them. Multiply n into log n. The time complexity here will be n into log n. That's it. Done. The time complexity of this code is n into log n. Let me move to the next one. Let me move to the next one now. Seventh example. Okay. How much time this code is taking? I starting with 1. We take the n value from the user. Fine. How many times this loop is executing? One thing you can notice in this loop is that here we have two increment statement. Here we have two increment statement over here. One is this and one is this. Here we are incrementing the I value by 2 and here we are incrementing the I value by, here we are multiplying I value by 2. Here we are adding and here we are multiplying. We need to take the I from 1 to n. Here we are incrementing by I plus 2. Here we are incrementing by I into 2. So what will be the time complexity? From which function I will decide, okay. If I take this function, the time complexity should be n, order of n, or you can say n by 2. Okay, because every time I am taking 2 step. So starting from first step, 2 means 2, 4, 6, 8. So every time jumping by 2 step. So in half step I will reach to the n. So the time complexity will be order of n. Constant we can remove. But here one more condition is there inside the same loop, which is telling the multiply. And whenever we see multiply, we say that should be log n. So what should be the time complexity? Order of n or log n? On which condition I have to decide? Actually, I need to take that condition which is impacting more. I started from 1. I want to go to the peak n. And you want to go to the peak. One person is helping you to take 2 step. Only 2 step. Another person is helping you to double whatever is the previous value, that is multiplying with 2. Whatever is the previous I value. If previous I value is 2, that is 4. 4 to 8, 8 to 16, 16 to 32, 32 to 64, 128. As the value is increasing, you are doubling, directly you are doubling. So this is helping more to reach to the n faster way as compared to this. So simply you can note here that, okay, which is helping more to reach to the n, to reach to the final position, that will be a time complexity. Okay, because that is impacting more. This is impacting more. This is not impacting that much. This is impacting more. So the time complexity here will be log n only. That's it. Okay. Fine. Okay. So you can take it as it is. Let me clear it and move on to the next example. So here is the next example. Example number 8 with us. We're taking an input. Fine. I value starting from 2. And here in this loop, we are taking the power of I. So it's this is I power 2. So every time we are taking the power of I. So let me give you first thumb rule for this also. Take a thumb rule directly. Whenever we have the power operator, let me write. Until unless I don't write, people don't blame me. So this is the power operator, okay? This is the power operator in Python. So whenever you see the power operator or square root you are taking, okay? Then any of them, then the time complexity, square root, let me write. So whenever you have any of them in the conditional statement, you simply says that the time complexity will be log of log n. Take it directly, okay? The time complexity will be log of log n. You see the power, close your eyes, say it's log of log n. That's it, done. Otherwise, if you want the mathematical proof, that will take 2 minutes. That will take 2 more minutes. So let me prove that, okay, this is really taking log of log n time. So let's see. Just I need to find out how many times this loop is executing. That's it. Let's see how many times this loop is executing. Okay, let me see. Starting with I value 2, fine. We enter inside the loop and then we take the power of I, 2 power 2. let me write 2 power 2. Now the I value is 2 power 2. One time we executed the loop. Again we enter. When we enter, then again whatever is the previous value, let me write the previous value, that is 2 power 2. Take the power of that as a 2. Okay, taken. Again we go inside the loop, and whatever is the previous value, so let me write the previous value, 2 power 2, again power 2. So whatever is the previous value, take its power as a 2. Okay, we take its power as a 2, fine. Again we will go inside the loop. So whatever is the previous value, we will take the power of 2. So let me convert into a series actually. So okay, what is this term? Okay, from here we can understand. What is this term? Can I write it like 2 power 8? You can multiply the power. 2 into 2, 4. 4 into 2, 8. You can multiply. And we have 2 power 8. Can I write it like 2 power 8 I am converting. Okay, 8 will be 2 power 3. What is 8? 2 power 3 I can write. 8 is what? 2 power 3. So 2 power 3. Okay, so if I replace this term with 2 power 3. Okay, let me write it. So I can write it like this. This term will be 2 power 3. And what is this term? What is this term? Okay, this is just like 2 power 2. And what is this term? 2 power 1. I need to generate the series so that we can solve it. So you can write it this 2 power 0. And if you will notice, next term, what will be the next one? Take the previous one. I'm taking previous one as it is. This is the previous one. Take its power 2. Take its power 2. And what is this? 2 power 16. What is 2 power 16? 2 power 4. And so on, this will keep moving until I don't know 2 power k. 2 power k. Until unless that will reach to n. That will reach to n. We will keep going on. So simply, if you will notice this topmost power, this is incrementing by 1. So this is deciding how many times we are executing the loop. So this k value is deciding how many times the loop is executing. So if we solve it, 2 power k is equal to n. That is the time complexity. So how we can solve? Taking the log both sides. Log of 2 power k is equal to log of n. This is the power. Take it into the front. We know the log property. Whatever is the power that come into the front, 2 power k into log 2 left over here. Taking the base 2. Okay, I'm taking the base 2 so that I can dissolve this term as a 1. So this term will be 1 now. We have 2 power k over here and log n over here. Further we can solve it. Okay, so this is right now I'm writing 2 power k is equal to 2 power k into 1 is 2 power k. This is log n. This is log n base 2. Again, take log both side. Take log both side. This will be log of 2 power k and this will be log of log n now. Take its log also. Right side log also. So now this k will come in the front. And here we have this term, which is 1 only. So I can say that k is equal to, what is this? Right side, log of log n. Yes, mathematically we prove. Mathematically we prove that, okay, how much time we are taking over here. How much time this loop is executing. How much time this loop is executing. Log of log n time, that's it. Mathematically we prove. So if you are not sure about this math, don't need to worry. What we need to do? Take the thumb rule. What is the thumb rule? Whenever you see power operator, in the increment section or square root operator, say that time complexity is log of log n. That's it. That much time the loop will execute. Directly take the thumb rule. Everywhere that will be applied. Fine, okay, this is the mathematical proof also if you want. Now let's move on to the next example. 9th one. And you can close your eyes and tell me what is the time complexity of this. Close your eyes and keep your hand on your heart and say that, sir, you told us whenever you are taking the square root, we are incrementing the I value, decrementing in this case, we started from n going to 1. We are updating the I value by square root. So time complexity will be log of log n. That will be log of log n. Take it directly. Otherwise, if you will solve it mathematically, the same term will come. The same term will come, log of log n. Fine, okay, if you will ask me, then I will provide the solution in the comment section. You can ask me over there. Otherwise, take it directly. Okay, this will also be log of log n. Fine, okay. Let me bring back my screen. Just a minute. Fine. Fine, okay. We have gone through all the different type of time complexities, especially for the loop only. Okay, only loop today we cover up. For recursion, for recursive type of codes, how to find the time complexity we will cover in future lectures. But if you even do not understand anything, don't need to worry. Give me 5 more minutes and I will go through all the time complexity immediately right now. So let me go through them. So, okay, I'm taking one example over here. Let's suppose we have a staircase. So, let me take the pen also. Let me take the pen. Here is my pen and I'm drawing a staircase. We have a staircase, fine. There is a girl standing over here, okay. Let me make a girl over here. So, she is standing over here, okay, and she want to, let me make the hand also. So, okay, fine. So I hope this she is a girl. Fine, okay. So might be he can be boy also. If long hair doesn't mean that okay she is a girl, but still okay. Let's assume she is a girl. She's standing at the 1th step and she want to go to the nth step. Okay, she want to go to the nth step. If I ask you, the girl is standing at 1th step. She want to go to the nth step. So n plus 1, this loop will go up to n step. She want to go to the nth step. Every time here she is taking one step, one. In how many steps she will reach to the top? In how many steps she will reach to the top? N step only, n step. So this loop will take order of n time to execute. So simply when we are incrementing by 1 every time, the loop will take n time to execute. And if somebody is at the nth step, so maybe there might be another girl standing over here at nth step. And she want to come to this last step, 1th step. Okay, she want to come down. Every time she is taking one step downside, 1 step. Okay, in how many steps she will reach to the 1th step? This girl, she will also take n step. One step she is taking and want to come at the 1th. She will also take n steps. So order of n time. So this loop will also take, either you are starting from 1 to n you are going, or n to 1 by taking one step. The time complexity will be n only. If we are taking two steps, you started from here, the girl starting from here and take 2 steps. One step she is jumping like a kid, she is jumping. In how many steps she will reach to the top? N by 2, half steps, because every time she is skipping one step. So taking two step, skipping one step, taking two step. So in half step she will reach to the top, n by 2. N by 2 is constant, remove that, time complexity is n over here. Same, this girl can also do, started from the nth position, which is standing at the nth position. She want to come down to the 1th position, taking two step downside, two step downside. So she will also take n by 2 steps to reach to the 1th step. N by 2, you can remove the constant. So time complexity is n only. What about she is taking 10 steps? She is now becomes spider woman. She is taking 10 step. In how many steps she will reach to the top? 10 steps she is taking, started from 1 going to n. 10 step. I don't know how she is making it, but she is doing like this. So how many times she will reach to the top? N by 10 steps she will take, n by 10 only. Okay, and n by 10 is constant, again in the same category. She also copy, she say that I also want to be, my weight is little high, it's okay, I also want to take 10 step. She may be jumping from here like a Spider-Man and coming down, she also coming down, and she will also take same time, n by 10. 10 is the constant over here, order of n time. Okay, fine. There's a loop inside loop, outer loop is taking n, inner loop is also taking n. So multiply when there's a loop inside loop. Time complexity is n square. So these are some of the functions we have covered while measuring the time complexity. Some more we discuss. These are some others, and we already know that, okay, by thumb rule itself, when we see multiply and divide, the time complexity will be log n. Whenever we see, okay, here what we are doing is we are again multiplying. Okay, here is the outer loop and there is the inner loop. Okay, outer loop and inner loop. Outer loop is executing n time, inner loop is executing log n time. So time complexity will be n into log n. Yes, we know this thing also. And whenever we see the power operator and square root, so power operator is incrementing the value. 2 power 2, that power 2. So we are going from 2 to n in this case. And in the square root, it started from n top, we are going down, down, down. Every time taking square root of I. So reducing its value. Reducing the value by using the square root. Whenever you are reducing the value by square root, then time complexity in both the case, simply that will be log of log n. Take it directly, take it directly. Fine, okay, these are the most important complexity functions. Let me see, is there something further? No, that's it for this session. Stay tuned, we will complete the DSA, we will master it to crack the GATE exam with below 100 rank. And don't forget to subscribe and like this session.